Hey everyone, welcome back to my channel where I'm teaching you the basics of Solidity and smart contracts on Ethereum. But today we're going to get into a more advanced topic, which is unit testing your smart contracts using Solidity. And we're going to do it with a new set of features coming to Remix, which is the Ethereum IDE, called Remix Tests, and it's unit testing within Remix. So what do we usually want to test when we write unit tests for smart contracts? Well, we want to test that everything works as expected. But something you want to test when you're writing unit tests is also what happens when something unexpected happens. What happens when you have invalid inputs? What happens when you have, in our example today, numbers that are really too large to be processed correctly within Solidity? Say you're multiplying two extremely large numbers that take up more than 256 bits to represent. What happens? Well, in Solidity, we have what's called an overflow, where it actually goes all the way up and then goes, once it hits that maximum 2 to the 256 minus 1, it goes back to 0 and starts counting up again. It's called an overflow. So we want to make sure that our function is not, our code is not susceptible to these types of overflows. And today we're going to use a pattern called Proxy Contracts, and we're also going to use them with the behavior of the lower level Solidity address call function, which lets you call functions within other contracts given an address. And it has this property where if it runs into an assertion that fails, or it runs into a revert, which halts the code execution, instead of halting code execution, it actually just returns false. It's an interesting property, but today we're going to use it to our advantage. And this technique is going to allow you to test using Solidity, test when your code execution basically fails because of a failed assertion or a revert. This is a bit more of an advanced tutorial, but if you're still with me, let's check it out. All right, so the first thing we're going to want to do is set up our example code that contains our assertion statement that we're going to test both positively and negatively. And for our example today, we're going to take a page from the OpenZeppelin SafeMath contract. If you're not aware, SafeMath is a contract that provides safer versions of addition, subtraction, division, multiplication, and modulus that prevent against things like divide by zero, although that's been fixed in more recent Solidity versions, but also things like overflows, which that behavior has not changed in recent Solidity versions. So you do have to be careful when you're multiplying large numbers together that you don't overflow the size of your integer and get a value that you don't expect. Could be a big problem, right? So first thing we're going to do is we're going to go into Remix Tests here, and we're going to set up our example code in a new test case. So I'm going to create a new folder here. And we'll call that test. And we'll call it test assert. And we'll go in here and create a new file. And we'll call it safe mult.sol. So to start, of course, going to declare our Solidity version. And then this is a library contract, and it's beyond the scope of this video to explain what a library contract is, but you can go check it out. It's basically, I don't want to get into it. Basically, you're going to borrow the functions for another contract. We'll call it safe mult. And we'll declare a function. And this I'm just taking directly from the OpenZeppelin SafeMath Solidity file. So we're going to take our two numbers, A and B, and we're going to return another integer. So the first thing that this contract does is to save some gas. If A is 0, we return 0. We're not going to really worry about that, but I'll just include it here so that it represents the SafeMath file correctly. And then we go ahead and say our C is A times B. Pretty straightforward, right? Here's where we check to see if we have any problems. If we have an integer overflow, which is basically the numbers we're multiplying together, the result is so large, it can't be stored in a normal uint 256. And so it goes beyond the maximum number of uint256 and starts again at 0. And so you end up with a much smaller number. So we're going to use the require function here. And what that's going to do, it's going to require that whatever this statement within this function is, whatever it evaluates to, it has to be true. And if it's not true, it reverts the contract call. And that's kind of the meat of this video. And so if that is true, we continue and we return C. Now, if it's not true, we're not going to return C. And what's actually going to happen is we're going to revert the contract call. And when you're testing with Solidity, that's going to be a big problem because it's going to basically halt execution of your tests, and you're not going to be able to evaluate what the return value of this function actually is. And so it makes it difficult to write tests, but we're going to fix that today using this pretty easy technique. All right, so here's our safe multiplication function. We'll go ahead and save that. Save. Okay, oh boy. All right, so the next thing we're going to do is we're going to write a helper contract that's going to be a proxy that allows us to call the methods within this library contract basically without using the library contract itself. And I'm going to show you the reason why we're going to do that, but for now, just trust me. So we'll call this safe mult proxy. Go ahead and go in there. And once again, we're going to declare our version of Solidity. Whoops, forgot the caret. And we're going to import the contract that we just wrote. So we'll call this the safe mult proxy contract. And when you use a library contract, you use this keyword in Solidity called using. And basically what it does is it allows you to borrow the functions from another contract and use them as functions on a data type. And those original functions that you're using, whatever the individual variable that you're calling the function from, whatever that is, it gets passed as the first argument in that function. So if I declare a uint a, and then I say a dot mul, that's gonna a dot mul, and then the argument b, that's gonna call this function, and the a dot mul, that a will be our first argument here, underscore a, and then the single argument in the function call, that will be our second argument here, b. So that's just a quick overview of what using does. And then we'll declare our function here, mul proxy. And all this is going to do is it's going to take two variables, just like our actual mul function that we previously declared. And it's just going to call it in the library manner, the way that you use a library function with the using keyword, like I just described, a.mul b. Okay, fantastic. So we've got our proxy contract set up. Now we're going to go ahead and write our test and explain why we use this proxy contract setup. So we'll call this safe mult test, and to remix test using the underscore test identifies it as a test case. Excuse me. And then once again, we declare our version of Solidity. Then we're going to go ahead and import our proxy contract that we just made. Whoops. Made a little error there. Hold on. Safe mult proxy. There we go. All right, so the first thing we're going to do is we're going to instantiate a instance of our proxy contract within this contract. So we declare it there, and then we use this before all function, which if you've ever done unit tests before, basically this function is going to run before we run our individual test cases. And we're going to set up our instance of the contract. Great. Now we're going to declare our test case. And this is where it gets good. Unsafe multiplication should overflow. So first we're going to test the bad behavior, the overflowing of a multiplication operation. And the reason that, my style here is really bad. I'm used to Python. The reason that we want to test that is when you're writing test cases, you not only want to test what you think should happen, you also want to test what you think shouldn't happen. At least that's the way I like to do it. All right, I fixed my spaces here because I'm not in Python. And I'm going to take my two variables that I'm going to multiply. So in this case, we'll use a as 4, and we'll use b as a very, very large number. And that number is going to be 2 to the power of 256 minus 1. And that's the largest number that you can store in a uint 256. Hence, that's why it's called the 256-bit integer. And now we're going to use our assert function. Now the assert function is, or rather the assert library, or the assert contract, excuse me, something that's included in Remix tests, and it's basically what allows you to check the results of your test. And the way that works is we're going to use the equal function from that contract, and we're going to say that a times b should be equal to 2 to the 256th minus 4. So what do we do here? We're using the concept of integer overflow, and we're going to overflow, because a is 4, we're going to overflow 3 times. So every time that we overflow, we're that value 2 times 2 to the 256th power minus 1. And so if we do that 4 times, we end up with minus 4. And then the last part of this function is what you want to display if the test case didn't work as you expected. So we'll say that our unsafe multiplication did not overflow. All right. Oops. All right, so there's our first function. Let's go on to our second function and test what happens when we use our proxy contract, and then where we assert that we don't have an overflow. So we're going to test to see if the contract stopped executing, and call the revert. So we'll say safe multiplication should revert. We return a bool as we do with our test cases. And we're going to do the same setup. But this time, we're going to do something a little tricky. So first, I'm just going to leave that out for a second. Let me finish this. Safe multiplication did not revert. So what would happen if we just used a regular multiplication? So we said Well, we've seen what happened, right? We get this weird number, 2 to the 256 power minus 4. That's not equal to 4 times 2 to the 256 minus 1, unless you modulus it by 2 to the 256 minus 1. Basically what I'm explaining here is that doesn't make sense, right? You wouldn't multiply 4 times a number and get a smaller number, right? It doesn't make sense unless it's a negative number, but it's not in this case. It's a positive number, so it should be bigger. But as we see in our first test case, it's not bigger. So in our original library function, what we do here is we check to see, after we do our multiplication, we check to make sure that we do the reverse and say, our result divided by A should equal B, right? If C is A times B, then C divided by A should equal B. It's like very simple algebra, right? And so we have a test here. Now, if you overflow, this test will fail, right? And it will stop execution of the contract or of the function. So how do we call that function and test to make sure that that assertion works? The way we do that is we use a lower level function call in Solidity. And if you look at the Solidity documentation, if you dig through it, you'll see a line that says that when you use the call function instead of just executing a function the normal way, if you use the low-level call function, instead of contract execution, function execution stopping and reverting, it actually returns false. And this is kind of one of the tricky parts of Solidity. This is kind of the stuff I think that you need to know once you get deep into Solidity and you're looking for security issues and arithmetic issues and things like that. So here's the tricky part. This call works on an address. So we're referencing a contract directly by its address. And we'll get the address of our safe molt proxy, excuse me, that we created earlier in our before all function. And like I said, we're going to use the call function. Now the call function, what you do is you provide some gas. You also provide a value, and that value is the amount of ether that you want to transfer along with the function call. And then the last argument is, basically that gives you the function that's ready to be executed. And so we use this last execution parentheses to say, on that contract, which function do we want to call and what are the arguments? So we're going to call molt proxy. I think that's what it's called, right? Yes, molt proxy. And then the second argument is a list of the arguments that you want to call. So we're going to use it on A and we're going to use it on B. And what should happen here is it should return false instead of halting execution. So hopefully I've got this all set up right. Let's see what happens when we actually go to run these tests. All right, so I'm here in remix tests, and we're going to execute the remix tests function, and we're going to execute it on our test assert test case. Let's see what happens. Oh, looks like there's some sort of typo here in safe molt test Solidity 773. Oh, you know what? I think it's something dumb. Well, it's not dumb, but I made a mistake. Let's see if that fixes it. And hopefully this video won't be too long. Try it again. All right, the eyes are watching us. We're running remix tests. Identifier not found or not unique. Oh, I said using safe math here, but we're not using safe math. We're using safe molt. All right. Hopefully we're in the clear. If you're watching this right now, you're probably saying, oh, there's another error, Dan. You need to go fix this. I'm skipping forward in the video. Hey, my apologies. I appreciate you guys sticking with me. Safe multiplication should revert public const nat. You're probably waiting the whole time for me to notice that. Where is that? Hey, I don't see that. Where is it? Safe multiplication should revert. Aha! Normally I have this other keyboard set up, but I need to buy a USB hub so I don't have to like reach over to the laptop. Let's try it one more time. If it works this time, I'm not going to edit it out. We'll see. All right. So what happened here? It deployed our contracts, and then it ran our individual Solidity test cases, and they passed. So we're all good. So that's pretty much it for this video. The key takeaway here is if you want to test a revert, if you want to test an assertion that fails, basically you're going to have to set up a proxy contract that calls those functions, and then you're going to have to call that proxy contract using the lower level Solidity call function. Something that's kind of dangerous to use in a real contract unless you know what you're doing, but in your test cases here is perfectly fine. And we use the property of this low level call function in that it returns false instead of halting execution when it comes across an assertion that fails or a revert. So yeah, this is my first kind of more advanced Solidity tutorial, more in depth on testing. Let me know if you like this type of video, if you want to see more of this type of more advanced content instead of my beginner stuff, and I'll see you next time. All right, everyone, thanks for watching. If you found this video useful, please give me a like and a subscribe. That will help other people like you to be able to find this video and get the information they need. Once again, thanks for watching, and I'll see you next time.